Good morning everyone. This is Swapna. Welcome to class. Today we are going to learn about the basic decision tree learning algorithm. Most algorithms that have been developed for learning decision trees are variations on a core algorithm. So it will take the basic concept of decision trees and also some variations are there. That type of algorithm, most algorithms are there that uses the decision tree learning concept as well as some other properties also employs. So here we are going to learn about that type of learning algorithms. Here it takes the core decision tree learning concept, this algorithm that also employs a top-down and greedy search through the space of possible decision trees. This approach is employed by this type of approach, that means decision tree learning algorithm concept and employing the top-down approach and greedy search approach that are exemplified, that are applied by the two types of algorithm here we are specified. First one is the ID3 and second one is the C4.5. This ID3 algorithm is invented by Quinlan in 1986 and C4.5 is also invented by the Quinlan only, but in 1993. ID3 means Iterative Dichotomiser3 algorithm. ID3 algorithm full form is Iterative Dichotomiser3 algorithm, and this is the basic decision tree learning algorithm which employs the top-down and greedy search approach. Top-down means it will start with the top of the, and it is every time it is going down. That means here it is using the decision tree approach that we can call as also root tree approach. It will start the process from root. After that it is going to the descendant nodes, like from top to down. And what is greedy search approach? Greedy search approach means it doesn't allow to go back and revisit or recheck of the choices. That we can call as greedy search approach. Now we are starting with our basic algorithm, that is ID3 Iterative Dichotomiser3. It learns the decision trees by constructing them top-down approach and beginning with the question, which attribute should be tested at the root of the tree? That means generally in the decision trees, all the attributes we are taking as a nodes, and these to branch from one node to descendant node, that branching is represented by possible value of that attributes. What are the possible values of that attributes are that we are representing with the branch. So which attribute we need to take as a root and which attribute it is to test to take it as a root, and after that which attribute we need to test as taking as a leftmost child or rightmost child or middle child, depending upon the possible values of the first attribute. So the best, for example, the best attribute we selected and used as the test at the root node of the tree. We took that one selected attribute we are considering as a best and we tested the root node of the tree. The descendant of the root node is then created for each possible value of that attribute. Descendant node for that root node is created depending upon what are the possible value or constraint value of that attribute. The training examples are all sorted to the appropriate descendant node. All the training examples are sorted and to get the appropriate descendant node. The entire process is then repeated using the training examples associated with each descendant node to select the best attribute to test at that point in the tree. That means this process is repeated every time with all the training examples whenever you are selecting the node. Selecting the node for descendant node best attribute at that point in the tree. This forms a greedy search approach. What is that approach means? In which algorithm it never backtracks or reconsiders whatever the earlier choices. That means when attribute is selected as a root means it and next to select the descendant node, it never going back to that root node attribute and it doesn't reconsider that earlier choice. So that we can call as a greedy approach. So greedy approach never backtracks or never reconsiders the earlier choices. That is the greedy approach. And every time the entire process is repeated for all the training examples to select the best attribute, to test. So this is about the ID3 or basic learning algorithm, which uses that top-down approach and employs the greedy search approach. What is greedy search? Now only we stick. Next. Now we are starting that. We are set now to selecting that best attribute to test as a root. And which is the best attribute? That means the best attribute which will classifies the instances easily. What is the main concept to use the decision tree type of learning is it is best suitable for the classifiers only. So to select the best attribute as a root and every time select the best attribute as a node, which will classifies easily with the shortest path, that we can consider as a best classifier. To get that one, here in ID3 it is using the one statistical property called the information gain to choose the best attribute to test. So it will use the one statistical property, that is the information gain. What it measures? Information gain measures how well a given attribute separates the training examples according to their target classification. So information gain measures that whatever the given attribute is, classifies the training examples or separates the training examples. So ID3 Iterative Dichotomiser3 uses this information gain to select among the candidate attribute at each step while growing the tree. So this ID3 Iterative Dichotomiser uses this concept of information gain. What is the information gain work means? It will measures that given attributes is separating the training examples according to your classification or not. It will check and it will measures that one. So that concept is used by the Iterative Dichotomiser3 algorithm, ID3 algorithm at each step while growing the tree. So next one. So to get that information, to define that information, first we need to know about the information theory called the entropy. So ID3 algorithm uses that information gain at each step to measure that one, the attribute is best or not, to classify the training examples, to classify the instances. To get that information, first we need to know the information theory called the entropy S. It characterizes, what is the entropy work means? It characterizes the impurity of the arbitrary collection of examples. It characterizes the impurity of arbitrary collection of examples. It measures that impurity of the instances. That is the entropy work. In given collection containing the S, containing the positive, in given collection is represented by S, entropy is also represented by S only. Given collection containing the positive and negative examples of some target concept. The entropy of S relative to this Boolean classification. Here we are considering only the Boolean classification. That means it is having the Boolean values to classify that instances is 1 or 0. So here in the given collection, generally it will contain the positive and negative training examples of the target concept. It needs to divide that one, differentiate that one, easily classifies that given training examples are given instances. For that, to find that entropy, here we are going to use the formula of this one, entropy S. What is the formula means? Positive log to positive P minus log to P minus. Here P positive is the proportion of positive examples in collection S, and P negative is the proportion of negative examples in collection S. In all calculations involving the entropy, these are the calculations we are going for the positive training examples and negative training examples. To define that entropy, here 0 log 0 we will get anyway 0. 0 log 0 we will get the 0. That we can call as the best entropy and best attribute. Next, for example, if all the positive is 1 and then negative is 0. All the positives are 1, they are target concept representing, negatives are represented with the 0. And entropy for this is positives. Only the one training example is there, only the positive training example. There is 0 negative training examples are there. Then what is that entropy value? That means here 1 log to positive training example 1, minus is there for calculation. So 1 log to 1, 0 negative training examples P9 log to 0, and for this minus 1 into 0, log 2 of 1 is 0, and here already we are having 0, log 2 of 0 is also 0, so what we are getting? 0. What we are getting the value? 0 for entropy. If there is one, all the members are positive members only and there is no negative members. Whatever the training examples are set of instances given to the learning system to represent that learning system with the decision tree. So all the training examples are positive, then what we will get? Entropy value 0 by this formula. Note that entropy is 1 when the collection will contain all the equal number of positive and negative training examples. If it is containing the equal number of positive and negative training examples equal, that we can call as will get the entropy value 1. So that is the worst case only. If the collection contains the unequal number of positive and negative training examples, then entropy is in between the 0 and 1. The collection may contain the unequal number of positives or negatives, then entropy value is in between the 0s and 1. We said if all the examples are positive training examples, then 0 negative training examples, we will get that entropy value is 0. If both positive training examples and negative training example both are equal, we will get entropy value 1. If collection will contain the unequal number of positive and negative training examples, then we are having the entropy between the 0 and 1. Suppose here I am taking the collection of 14 training examples and these are having the Boolean concept only. That means target concept value is 0 or 1, yes or no. Here these collection will include the 9 positive training examples and then 5 negative training examples. So what is the notation we are adapting to represent these positive and negative training examples is like this. 9 plus means 9 positive training examples, 5 minus means 5 negative training examples. To summarize the data, then we need to find out the entropy of S relative to the Boolean classification. Here we are considering only the Boolean classification, that is 0 or 1. So we need to find out the entropy. So find the entropy. Here we are giving the formula. We are replacing these values in the formula, that is 9 positive, 5 negative. Here minus symbol is there in the formula, and here positive training examples. Proportion of positive training examples. P positive means proportion of positive training examples. What is the proportion of positive training examples? 9 positive training examples in the collection of 14. So that we are representing 9 by 14, and also P plus log to P plus. Proportion of positive training examples log to positive training examples. Next, minus negative training examples log to negative training examples proportion. How many negative training examples are there? Means 5. What is the proportion? Means within the collection of 14, 5 by 14. That we are represented, and what are the value we are getting by this calculation is 0.94. It is in between the 0 and 1. We said already if entropy collection is having that unequal number of positive and negative training examples, then the entropy value we will get in between the 0 and 1. If all the positive training examples are there, then entropy will get the 0. If both are having the equal number, positive and negative training examples, then we will get the 1 entropy. That is the worst case only. So if unequal are there, then we will get the some points value which is in between the 0s and 1. So for this example, which are having the collection of 14 training examples, 9 positive and 5 negative training examples, there we will get the entropy of 0.94 in between the 0 and 1. So here, to represent that entropy, we took as a graphical representation. This is 0 to 1. If all the positive training examples are there, we will get the entropy 0, and both are equal means we will get the entropy value 1. So the entropy function relative to the Boolean classification as the proportion of positive and that is positive training examples varies with the negative training examples between the 0 and 1. Like this, we will represent that entropy. So is that clear? This is the entropy information. So more generally, if the target attribute can take on or see different values, till now whatever the collection of examples we are taking, only the Boolean value target concept. That means target concept is having only the two values of classification, 0 or 1, 0 or 1. But in real time, we will get the target, we will get the instances, different training examples are instances which are having the more classification. That means more than that Boolean value. For example, I am taking the collection of images, 20 images. Here I am having that classification or target concept values are animals, vehicles, birds. So I took some collection of images which is containing the images of animals, images of vehicles, images of birds. That is here in this example I am having the 3 classifications. So like that in real time application, in target attribute may contain the different values, not than the Boolean value, neither or not than the Boolean values, it may contain the different values. Then if it is having the more than that, C is wise of classification, that we are represented with the C classification, target concept or target attribute classification. Here we are representing with the C. For that also, what is the entropy formula to find out the entropy of that collection of training examples? How we are going to find that? Means for that entropy formula is like this. Entropy is generally represented with the S, and this is the formula. Summation of I value is equal to 1 to C, depending upon how many number of classifications are there. From that classifications, take from 0, I is equal to 1 to that many that are represented with the C only. And this is the formula, minus Pi log to Pi. For every classification, whatever the training examples you are getting, that you are applying on this formula. So that by that we can get the entropy. Here what is Pi? Pi is the proportion of S belonging to the class I, for which class this training examples belongs, that is represented with the Pi. Note that algorithm is still base 2 only. Here we are also using log 2 base 2 algorithm only, because entropy is measure of expected encoding length measured in bits only. Here entropy measures encoding length in bits only. That's why we are taking the base of 2 only. Note also that if the target attribute can take on C possible values, the entropy can be as large as log to C. So if you are taking the different classification, C type of possible values of classification, then we will get the entropy as large as the log to C. This is about the entropy, which is used in information gain. Information gain is used in ID3 algorithm. So next class, in next video, we will continue with the how to measure the information gain. So in this video, we started with the basic decision algorithm, and we what are the requirements are there to continue with the basic learning algorithm, that is ID3, Iterative Dichotomiser3. Iterative means it is continuing, it is repeated, it is having the repeated action. and dichometer measure. Dichometer means here it splits into the different parts according to the classification. If it is a Boolean classification, it splits the training examples into the two types, that is, which will contain the Boolean valued functions of 0 or 1. Otherwise, depending upon the classification, it splits all the instances and training examples into different classifications, and it represented in the form of tree. That is the dichometer meaning. To get that information gain. Information gain only measures that which attribute is best. Which attribute is best and which attribute will give the best subtree or best decision tree learning algorithm. To know that, we need to find out the entropy. So that then now we covered with the entropy. In the next part of the video, we will continue with the information gain. By this I am closing. In next video, we will continue with the information gain measures in ID3. So, once again, thank you. We'll meet with the next video.